Unit 3, Matter Around Us. Introduction. Matter is all around us. The air you are breathing is also a matter. Matter is defined as anything that has mass and takes up space. Matter is found in three major states: solid, liquid, and gas. So, what is matter made of? All matter is made of atoms. Atoms are the smallest particle of matter. They are so small that you cannot see them with your eyes or even with a standard microscope. A standard sheet of paper is about millions atom thick. Science has come up with a technology to identify structure of atoms scanning electron microscope SEM and tunneling electron microscope TEM, which uses electricity to map atoms. There is more about atoms in the latter, but first let's learn about the three states of matter. Silicon atoms on a surface via scanning tunneling microscope STM. Take a few crystals of sugar, observe them carefully with the help of a magnifying lens. Besides solids, liquid and gases, there are two more states: plasma and Bose-Einstein condensed states. Plasma is not a common state of matter on Earth, but may be the most common state of matter in the universe. For example, stars, including Sun, are covered in plasma. Bose-Einstein condensate is a gas-like state of matter that exists at extremely cold temperatures. It was predicted around 1925 and confirmed in 1995. This is used in the field of cryogenics. Activity 1. Take a few crystals of sugar, observe them carefully with the help of magnifying lens. Which of the shapes given above resembles a sugar crystal? A or B or C or D or E or F. Materials required are 1 hand lens, 2 sugar. The process is: take the hand lens with your hand, view it, zoom it, adjust it in the sugar crystals so that we can able to view this kind of sugar crystals by means of the hand lens. So, which of the shape gives above resembles a sugar crystal? For me, the answer is D. Now, place a few sugar crystals in a teaspoonful of water. What happens to the sugar crystals? Materials required: 1 sugar, 2 200 ml of water, 3 500 ml of glass jar, 4 spoon. Process: take sugar in the spoon and mix it in 200 ml of water and stir it well with the spoon until the sugar dissolves. So now you can able to tell that where does the sugar gone? It has been completely dissolved in water and we cannot able to see that sugar in the water. We can see this in the following video. This is how I am adding sugar. This is how I am stirring the water with sugar crystals. We can able to see the sugar is slowly dissolving in the water. Stirring again, the sugar crystals will dissolve in the water. Slowly we can able to see that the sugar is dissolving in the water and there is no sugar crystals seen in this water. You can see there is no sugar crystals in the water. At last totally all the sugar crystals has been dissolved in this water. Like everything else, a sugar crystal is also made up of molecules. When sugar dissolves in water, the sugar crystals break down and the molecules of sugar get distributed in the water. This makes the water taste sweet. The sugar molecules are extremely small. That is why we are not able to see them. A small amount of any matter will have many million molecules. Do you know? Besides solids, liquids, and gases, there are two more states, plasma and Bose-Einstein condensates. Plasma is not a common state of matter on Earth, but may be the most common state of matter in the universe. For example, stars including Sun are covered in plasma. Bose-Einstein condensate is a gas-like state of matter that exists at extremely cold temperatures. It was predicted around 1925 and confirmed in 1995. This is used in the field of cryogenics. Physical nature of matter. Matter occupies space and has mass, but what is its nature? Ancient philosophers pondered over such a questions. In India, a philosopher named Kanda and in Greece, a philosopher named Democritus came to somewhat similar idea. Imagine you have a piece of thread. You cut it into two with the same piece. Take again one of the piece and cut it again into two. Repeat the above process for many times. At some point piece of the thread will be so small to see, or we may not have sharp enough knife to cut further. But this is imaginary thought experiment. Therefore, these are not possible practically. Imagine if you can cut as fine as possible and are able to see even the very small things. Can we cut the rope into two without an end? Kanda and Democritus said, no, we cannot go on endlessly. There will be a point at which we will not able to cut the thread further. This is the point when we will reach molecules or atoms. We will read more about molecules and atoms later. Suffice to say that all matter is made up of very small particles. Gold is made up of tiny gold particles and water is made up of tiny water particles. These tiny particles present in all matter are called as atoms or molecules. The particles in matter are extremely small and cannot be seen even with a powerful microscope. What we can see is only group of particles. Characteristics of particles of matter. Particles of matter have a lot of space in between them. In different forms of matter, this spacing will be different. Let us add a spoonful of sugar to a glass of water. Stir well. Sugar disappears completely, whereas it has gone. Will the glass of water be now sweet? Particles of matter attract each other. It is this attraction which keeps the particles together. This attractive force will be different for different forms of water. Do you know that a drop of water contains about 10 to the power 21 water particles? One dot that you make with your pen has more than 2 lakh molecules. Grouping of matter on the basis of physical states. The above diagram shows atom structure and it is having neutron, proton, nucleus and electron. This atom is so tiny that it makes a group of molecule. That group of molecule will be giving rise to a physical state. You already know what grouping is all about. Matter can be grouped into solids, liquids and gases based on the above characteristics. These are called the physical states of matter. Mass, shape and volume of solids, liquids and gases. Let us first take any solid, say a stone. Answer the following questions. Do you need any container to know the shape of the stone? Yes or no? My answer is no. How? Let's see. If you move the stone from the ground to a table or place it on the shelf, does its shape change? Yes or no? My answer is no, because I am taking the stone and keeping in table, the shape of the stone will not change. A solid does not need a container. It stays where it is because its particles are tightly packed into a definite shape that ordinarily does not change. If you take the stone from the ground, Place it on the table or shelf, its shape and volume do not change. Sit together in groups of 3. Look at the following objects. All these are familiar to you. Are they all same or different? Can you pick out a few which you think are similar and group them? On what basis did you group them? Is there only one way of doing it or more ways? Discuss with your group members and note it down. You can group them according to their uses, the materials with which they are made of, or some other properties, and also as living and non-living things. For example, pencils and books are used for studying. The bucket and the comb are made up of plastic, while the table and ladle are made up of wood. The scrub brush and broom are rough, but the toy bear is soft. Light can pass through the glass of water and the spectacles, but not through the apple or iron box. The cow and the bird are living things while the rest are not. Water in the glass is a liquid, but air in the balloon is a gas and the rest are solids. The feather and the paper cup can float, but not the apple or the piece of stone. The rubber band can be stretched, but not the comb. Thus, we can see similarities and differences between things and group and sort them in many different ways. Try to fill in the following table. Write it or copy it in your notebook and do that. Matter around us. Anything which occupies space and has mass is called matter. The first one is LPG. It's a gas format, so that only it is pressurized inside the gas cylinder. The second one is iron, which is solid. We can able to see the iron materials around our home also. The third one is wood. It is also solid. The fourth one is liquid, which is oil, and you can able to see that in your home, in your kitchen. Number 5 is water, that all we know is liquid. It is all around us and also we are drinking it. Activity 3. Work in a group of 2. Malhar was asked to group some items based on their physical states. This was the table she made. Do you agree with her? Redo the table if you do not agree and submit it to your teacher. Since we are studying in home because of Corona, do the homework in your notebook and after that submit it to your teacher. The table column shows a group of things which is mingled together as solid, liquid and gas. She made a table as solid, liquid and gas, but the arrangements here are misplaced. So try to arrange all the items here as solid, liquid and gas. How did you classify items of the above list as solids, liquid and gas? You should have done it based on some properties. Items like brick and door, which are hot, comes under solids. Things that flow comes under liquids, and other which are very light and can flow more freely comes under gases. Well, you are right. Take a look at the figure given below. What do you observe? Particles in a solid, particles in a liquid, particles in a gas. In a solid, the particles are tightly packed with very little space between them. Example, stone. Particles in liquids are arranged in a random or irregular way and the space between the particles is greater than that in solids. Example, water. The particles in the gases are arranged far apart. They move freely. Example, air. Fact 5. Liquid atoms are packed more loosely, which allow things to be able to pass through it. Liquid is affected by gravity more than anything. Liquids are always moving due to gravity around it. A gas atoms are spread out so far you can walk through it without any restriction. Gas is not affected by gravity. The gases atoms never stop moving and it never stays in a place. Movement of particles is restricted in solids and they do not diffuse like liquids or gases. In fluids, the particles are under motion and hence can push ink or smoke particles here and there. Test yourself. Name an object which is brittle and transparent. My answer is glass. You make your own answer. Name an object which can be stretched. My answer is rubber. You try your own answer. Name two objects which can be bent. My answer is iron rod. You make your own answer. Activity 4. Lift an uninflated cycle tube. Inflate it and lift it again. Is there a change in the weight? Can we see the air has mass? Tell your answers. Tell your answers. So we can say that air is also matter, though we cannot see. Let us try to know more about matter. We saw that matter can have different properties. Let us take a 2 sachet of juice. In both sachets it is written 100 ml. Let us empty 2 sachets and pour the juice into the following glasses. Does its shapes also change? Yes or no? Does its shape also change? Yes or no? My answer is yes. Does its volume change? Yes or no? When it is poured into a big glass or a small one? My answer is no. How will you find out whether the volume has changed or not? You can able to measure it in a measuring jar. A liquid needs a container and takes the shape of a container because the particles slide past one another and keep moving. The amount of juice is the same in both glasses. The volume of a liquid remains the same whether it is kept in a large container or a small one, but its shape changes. Try to draw the shape of the liquid containers alone in your notebook. What do you observe? Think to learn. Solid to gas to liquid. Liquefaction of gases is a process by which substances in their gaseous state are converted to the liquid state. When pressure on a gas is increased, its molecules come closer together and its temperature is reduced, which removes enough energy to make it change from the gases to the liquid state. Compressible as compared to liquids and solids. Scan this QR code for the experiment what we are going to learn. Let us take 3 identical syringes, close the nozzles tightly with a cork. After removing the plunger, first let us fill it with fine chalk powder. Now the plunger back and try to press it down. What do you observe? See, solids are not compressible. You cannot able to press the chalk powder in the syringe. Liquids are hardly compressible, like we can able to slightly compress the syringe plunger. The third one is gases. They are compressible and you can able to press the plunger up to the max. Now let us fill the second one with water. Try pressing the plunger down. What do you observe? Let us now draw the piston back to suck air into the third one. Press the plunger down. What do we observe? Is it easy or hard to press? Record your observations and share among the group members. You would have observed that the plunger moved freely when air was present, and in the case of water and chalk powder, it was difficult to press and the piston hardly moved. We conclude that gases are highly compressible as compared to liquids and solids. Solids, liquid state, gaseous state. Solids have definite shape and volume. Liquid state have no definite shape. Liquids attain the shape of the vessel in which they are kept. Gases have neither a definite shape nor a definite volume. Solids are incompressible. Liquid state compressible to a small extent. Gaseous state highly compressible. In solid state, there is a little space between particles of solid. In liquid state, these particles have a greater space between them. In gaseous state, the space between gas particles is the greatest. In solid state, these particles attract each other very strongly. In liquid state, the force of attraction between the liquid particles is less than solid particles. The force of attraction is least between gaseous particles. Particles of solid cannot move freely. Particles of liquid can move freely. Gaseous particles are in continuous random motion. Matter can be divided into pure substances and mixtures. In pure substances, it can be divided into two, that is element and compound. And the mixtures are divided into homogeneous mixtures and heterogeneous mixtures.